Welcome to Tutor Sam Academy, where complex is made simple. Today we're Elementary Set, Part 2. Before we dive into it, subscribe to our YouTube channel.
Welcome. In my last video, we talked about set theory. We looked into the definition of set and set notation. But we'll be continuing on types of sets. If you have not watched that video, you can do it to watch that. Then here we'll be discussing about the types of sets. Now, when we're talking about the types of sets, I will start with what we know as one, the universal set. Universal set. Now, universal set, the set which contain, universal set is a set which contain all the possible elements under consideration. When you are considering numbers, let's say number between 1 to 10, your universal set will contain 1, 2, 3, 4, down to 10. So, universal set is a type of set which contain all the possible elements under consideration. Universal set is denoted with something like this. Universal set is always denoted with something like this. So, if you are considering numbers or set of numbers or set of integers from 1 to 10, your universal set will have this. Your universal set will have this. 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is what universal set is all about. The second thing is what we call the null set. Null set. Null set. Null set is a type of set which has no element at all. It is called an empty set. It is also called an empty set. It's a type of set which has no element at all. It is denoted with this. With this bracket is called a curly bracket. So when you see a curly bracket with no element, this is a null set. Or this is also an empty set. Empty set, I come again, is a type of set which contains no element at all. It doesn't have any element. So, for instance, you are considering number from 1 to 10. You now say, in this consideration now, you are looking at maybe 20. Why 20 is not part of your universal set? So that type of set that doesn't contain any element at all is referred to as what? An empty set. Another type of set is what we call a singleton. Singleton. Singleton is a type of set that contains a single element. For instance, I have set A. Set A has 1 as an element. So this is a type of a singleton. The type of set that contains one element. It is also called a unit set. A unit set. So this is all on when we are talking about the type of set. We've talked about a universal set, a null set, and a single set. Now let's look at the algebra of sets. Having looked at types of sets, let's talk about what algebra of set is. The algebra of set deals with set operations. That is, every operation that deals with sets. It can be the union of a set. It can be a complement of a set. So when we are considering the algebra of a set, we talk about what all those things. Now let's start with 1, the union of sets. Union of sets. Let's say the union of two sets, A and B, denoted by this union of sets. Let's say A and B. This is A union B. It's more like a U, but it's not a perfect U, or this kind of C that is upward. So a union of two sets, A and B, denoted by this, is a set which contains all the elements combined in either set A or set B. So the combination of all the elements in A and B is what we refer to as a union. You know that in marriage, when we're talking about union is the coming together of both man and woman. So the combination of both of them form what we call couples. But in sets, when all the elements of A and B join together, that is what we call union of a set. Let's take example. Set A is 1, 2, 3. Set B is A, B, C. So A union B is what? Will be combination of everything. You can start with your number, then proceed to your alphabet. So this is what we call the union of set A and B. We also have another type of algebra we'll be considering is intersection of sets. Now, two sets A and B, let's say X, no, don't let me use A and B again. Let's use X and Y. The intersection of X and Y denoted by this. Intersection of X, intersection is denoted by this. This is intersection, this is union. Please know the difference. This is union, this is intersection. The intersection of X and Y denoted by this is a set of all elements which belong to both X and Y. The intersection, the point of intersection means meeting. What join both of them together, what they have in common is referred to as intersection. Example is this. X is 1, 2, 3, 4. Y is 2, 4, 6, 8. So X intersection Y is what will be, what did they have in common? This is 2, this is 4. So 2, 4 is what we know, is what we represent as intersection of a set. The third algebra we'll be considering is complement of sets. Complement of sets. Now, listen very carefully. When we are talking about complement of a set, complement of a set, let's say set A. Complement of set A means that if A is a subset of a universal set, I've explained what a universal set is. That is, if A is part of your universal set, we can say A complement is elements that are in that universal set that are not in set A. I come again. Complement of set, if of set A, having known that A is a subset of your universal set, A complement means elements that are in your universal set that are not in set A. Let's give a universal set. Before this, we have a universal set of 1, 2, 3 to 10. Set A is 2, 4, 6, 8, and 10. So A complement, this is A complement, A prime. It is also called A prime. Or there are some texts they represent it like this, A complement. So A complement will be what? Elements that are in your universal set that are not in set A. 1 is in your universal set, 1 is not in set A. So 1 is a member of your A complement. 2 is here, so 3 is a member of your A complement. 5 is a member. 7 is a member. What are other members again? 7 is a member. Then we have 7, we have what? 9. 9 will be a member. So this is what complement of a set is. The fourth algebra of a set we'll be considering is what we call disjoint set. Disjoint set is a type of set. Two sets are said to be disjoint when they don't have anything in common. That is, they don't have anything in common. The intersection of two sets A and B is empty, then the two sets are said to be disjoint. When the intersection is empty, those sets are disjoint. I'll tell you what this intersection is. Let's say we have A. A is 1, 2, 3. B is A, B, and C. A intersection B. They don't have anything in common. This is an empty set. So this type of set, these two types of sets are said to be disjoint. They are disjoint because A intersection B is equal to an empty set. The next algebra we'll be considering is what we call the cardinality of a set. Cardinality of set. Cardinality of set means the number of elements in that set. Cardinality of a set, the number of elements in a given set. Cardinality of a set is the number of elements in a given set. This set has how many elements? This is 3 elements. The cardinality is not 3 because 3 is here. The cardinality is 3 because we have 3 members here. The cardinality of this set is 3 because we have 3 members here. The cardinality of this set is 5 because we have 5 members here. Not because I have 5 here, but because there are 5 members here. The cardinality of this set is 5. The cardinality of this universal set is 10. And cardinality is denoted as this. And if it is set A, you want to write the cardinality of A, you represent it like this. If it is set B, and you want to represent the cardinality of set B, you represent it like this. So this is cardinality of set A, and this is cardinality of set B. Finally, under the algebra of sets, we'll be considering power set. I think this is the 6th one. Power set. Power set. Power set, let's say we are considering set A. I like using set A very well. If we are considering set A, the set of all subsets of a given set A is known as a power set. The set of all subsets of a given set A, that is, set A consists of 1, 2, 3. The set of all the subsets, there are some subsets. I'm going to explain subset after now. You understand what subset is better. The set of all the subset of set A is referred to as power set. Power set is represented as P. Power set of A is represented as this. And it has a formula. Formula is 2 raised to the power of n, where n is the cardinality of the set. Cardinality means the number of elements in that set. So for this set A now, because we have 2 raised to the power of n, this is 1, 2, and 3. There are 3 elements here. This will be 2 raised to the power of 3, which is 8. So this is how to calculate the power of a set. Now, if we are asked to list this possible subset in this set, that will make the power set to be A. The possible subset will be set A. This is, we have every set has an empty set. So you consider the empty set first. You consider 1. Consider 2, consider 3. Now you consider 1 and 2. You consider 1 and 3. You consider the one I'm picking them back. Now, I've considered 1, 2, 1, 3. Now 2, 3. 2, 3. How many subsets do I have now? This is 1, 2, 3, 4, 5, 6, 7. Now you now consider a set of the 3. So you consider 1, 2, and 3 as a set. So these are possible subsets in set A. See, this is what make up this 8. 1, 2, 3, 4, 5, 6, 7, and 8. I believe you understand me very well. First thing, if you are asked to find a power set, this is how you calculate it. But if you are asked to list the possible subset of the set, these are the possible subsets that you can get from this set A. So if you have watched me to this point, do it to like, subscribe, and share. Now let's consider what we mean by subset and a superset. I've been using that word subset. Now what does subset mean? If I have two sets A and B, I can say A is a subset of B if and only if every member of A is also a member of B. That is what we mean by a subset. And a subset is denoted by this. A is a subset of B. This is how subset is denoted. I come again. Subset means every member in A is also a member in B. That means A is a subset of B. So I have this set. This is 1, 2, 3. B can be, it can still be 1, 2, 3. Every member of A is in B. A is a subset of B. B is also a subset of A. But there are times I can still have this 5. Look at this. You can see that A, everything in A can be found in B. This is what we mean by A is a subset of B. Now B, which hosts A and every other thing and still have additional to it, B is referred to as the superset. Super is the one hosting A. So I can say that superset is represented with this. B is a superset of A. This is A is a subset of B because everything in A can be found in B. B is a superset of A because it's hosting A and it still have additional element to it. Thank you very much for watching. If you have watched me to this point, don't forget to like, subscribe, and share. Thank you.